And hello all, Mr. Callan here with you for the e-learning assignment. Wednesday, April 29th to Wednesday, May 6th. Cannot believe it's almost May. A lot been going on. This is the overview for today. Focus today, once again, our same learning objective as Monday. I will convert very large and very tiny numbers between standard and scientific notation. They are the same numbers, just two different ways to write it. Some people call me Mr. Callan, some people call me Uncle Tim. I'm the same guy. Today I will review and learn and practice, as well as understand why we sometimes prefer scientific notation. And I'm going to come on down here. We got a video, you're watching it now. We got practice on Khan Academy, and then some pretty sweet challenges for those of you that are looking for a little more and find today's stuff pretty nice. Let's go on to review our exit problems from Monday. How were all the problems that were given similar? How are they all different? And kind of write a step-by-step. Now, I wish I would have written those questions a little better so that you looked at certain problems. But these are the few of the answers they had. All had numbers in the equation. They all had decimals. Several people saying they all have decimals. All have powers of 10. Zeros came up quite a bit. More on zeros later. Mostly long numbers, that's true, and that's kind of the big point. Why do we use scientific notation? Think about measuring a distance from here to the moon. The scientists could sit there and write zeros for a whole chalkboard's worth, or they could write the number very quickly, efficiently in scientific notation. And let's move on then. How are the problems different? Some have positive and negative. I think what that person might have meant was positive and negative exponents. A number of people wrote difference between positives and negatives. Meanwhile, different because they have different numbers, a good place to start. And numbers 9 through 16 have negative exponents while others don't. I really like that person being a little more clear with what the positives and negatives meant. Step-by-step instructions was a little more difficult. Some people didn't look at the directions to only look at the numbers, the problems in the assignment, changing normal or standard form into scientific notations. Let me share a couple of them that I got. If you want to change the number to scientific, move the decimal to the end. I'm not sure exactly what that person means, but it certainly will take moving some decimal point. Count the number, and that will be the exponent. Going to talk more about the number and the exponent in a bit. The next set of instructions, where the decimal's at, and you have to move it to the right. Well, sometimes it moves to the right, sometimes it moves to the left. I don't really want us to focus on right or left. I want you to focus on huge or tiny, because that's going to tell us, is it a great big amount, positive exponent? Is it a tiny, tiny portion? That would be the negative exponent. But I like the fact they also put the decimal between two numbers, count how much you moved, put that as the power, as the exponent. Next person, went down a little too far. Find the number, find the first number of the problem, and go in between the first and second number. Again, more on where that decimal point should go in a bit. Count from that spot to the end. Maybe we should say to where the decimal point belongs. Take the first two numbers, use it as part of not really an equation, but part of the expression. And they even gave an example here. 75 thousandths is the same as saying 7.5 times 10 to the fourth power. Now, next one also talks about standard form, where to move the decimal. Then in the number it has zeros. And now be careful counting the zeros. That's what I'm going to talk about a bit right now. But first, I want to talk to you about the whole point of standard and scientific notation. So the whole point is, really, it's two ways of representing the same thing, just like Mr. Callan, Uncle Tim, whatever. I'm the same person, just different ways of representing who I am. So that's the whole goal. I want you to keep that in mind. Now, yes, we do want to move the decimal point. So some people are struggling where? Well, you always want to keep the decimal between make a number between 1 and 10. Now, it could be exactly equal to 1 or bigger than 1, but it has to be less than 10, because if you had 10, you could move the decimal point one more place and make it a 1. All right? So greater than or equal to 1, less than 10. Multiply that number by a power of 10, and then set the exponent up as the number of times the decimal place is moved. Several people just counting zeros here. It's not about zeros, and maybe I can show you an example of that in a second. But again, I want to bring us back to the whole point. When you rewrite this number, it should be the same amount of money, just two different ways of writing it. Or it should be the same tiny, tiny, tiny length of a foot, but just two different ways of writing it. Now, the practice is in Khan Academy. If you look closely, you see that, yes, even Mr. Cowan gets some wrong. I got the very first one wrong, and I learned from my mistakes, so don't worry about it. 5 or more correct out of 7 is going to be 70% or higher. That's how you know you're good to go. If you get below 70%, then you need to redo the assignment over and over until you get it right. If you try it 2 or 3 times and are still struggling, that's when you email or message me and see if I can help. Now, I do have some examples here I want to talk to you about. First 2 problems are given to you in scientific notation. Change them to standard. I'm going to copy the 5 and 6/800ths, but now look, what does this big old thing mean? I shouldn't have said big old thing, because as soon as I see a negative exponent, I'm thinking change it to its reciprocal and turn the nonsense into something that makes sense. So literally, this means 100 millionth of a dollar, or 100 million. Okay, so if we're talking about a tiny, tiny portion, then we better make sure that we move that decimal point to make a tiny portion. I don't think to the left or the right. I think huge number or tiny. So we're going to move it 8 places to the left. 1, 2, 3, 4, 5, 6, 7, and 8. And then we're going to fill in all those places with zeros. And then, of course, I could put that 0 out in front. In fact, why don't I write it here? But notice there are not 8 zeros in between the decimal and the 5. There's actually 1, 2, 3, 4, 5, 6, and 7. But you might notice that the 5 is in the 100 millionth place. And sure, we have parts of 100 millions. Just a reminder, these 2 lengths is the same exact length. It's just a different way of writing it, and quite frankly, I think scientific notation is a little more neat, tidy. Now let's take a look at the next problem, and if I were to write 3 down here, I guess the important part is, where should the decimal point start? You'll notice the problem on the left has the decimal place, but the problem on the right doesn't. So if you will way down to the right-hand corner, just ask yourself, which of those is 3? And if it helps, put some zeros in there, and you're going to see very quickly, shouldn't be that. So I'm going to place my decimal point, but ask myself, is this a huge or a tiny, tiny? Well, this is 10 times 10, and so on. That's 100,000. So I better make sure I move it 5 places, 1, 2, 3, 4, 5, and make a huge number. And if I were to rewrite that, this is one of the rare times when the exponent matches the number of zeros. It usually doesn't. But again, to point out, if I asked you, would you prefer the number on the left, the amount of money on the left, or the amount of money on the right, you're going to say, come on, Mr. Callan, that's the same amount of money. It's just 2 different ways of writing it. Now we look at the opposite perspective, changing standard normal form into scientific form, scientific notation. Remember, please, that we always have some decimal times some power of 10. But the question is, where should we put that decimal? So if you take a look here, I could ask myself, which of these numbers makes a number between 1 and 10? Naturally, 8,000 too big, 804 too big, 80 too big. What about this one? But this one is smaller than 1. And so very quickly I learn how to make a decimal between 1 and 10 just by saying, where should the decimal go? Somebody said between the first 2 numbers, which I thought was clever. And so we could write it that way. So I'm going to go ahead and write 8.043, but I have to ask myself, where would that decimal go? If I put a decimal right here, but this is actually home base, this is where it belongs, then I'm going to see 1, 2, 3, 4, 5, 6, 7, 8, 9. But I have to ask myself, is it huge or is it tiny? Because this is a huge amount of money, that I better make sure this power of 10 is a huge amount. Putting a negative would make a billionth of a dollar. That's not what we mean. So a reminder, that if I asked you which amount of money you would prefer, you're going to say, Mr. Callan, I already know these are the same amounts of money. Both of them say $8 billion. Both of them have parts of billions of dollars. They're just different ways of writing it. Now we'll take a look at the next one. Again, we want some decimal times some power of 10. So if I come down to all these 5 and 3s and I put different possibilities, there is only one of those possibilities that will make a number between 1 and 10. 53 is too big, 53 hundredths is too small. So we can now write 5.3. However, don't tell me that those amounts of money are the same. How is $5.30 the same as this tiny, tiny amount? It doesn't work, does it? So if this is where we believe the decimal point should, oops, let's put that 3 back. So if this is where we believe we want the decimal point, but over here, way over here is where it belongs. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But again, I have to ask myself, should that be a positive or a negative 10? Well, very clearly, one of those is a tiny, tiny, tiny portion of a dollar, and that's where the negative exponent comes in. And you know what's coming. If I asked you which amount of money or which length you would rather have, you're going to say, come on, Mr. Callan, I get it already. It's the same amount. Just to remind you, though, some people think and come up with a little shortcut about going to the left or going to the right. Well, what if I went the other direction? Then that shortcut doesn't really fly. Well, which is it? Is it going to the right? Is it going to the left? How about this one? Is it going to the right? Is it going to the left? So don't worry about left to right. Just think huge, then it better be a positive exponent because you keep multiplying by 10 over and over and over again. Or think tiny, thus a negative exponent, because what does this negative exponent mean? It means the reciprocal, and then it becomes positive. All right, folks, that's all I have for you now. Take your time, do well, go to that Khan Academy, and please, 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 if you need some one-on-one time, I can do some quick tutoring. Let me know if I can help. Email or message me. Thank you.